Hey guys, this is Alex and thank you very much for stopping by. Really appreciate your visit. And today I just want to focus my efforts in trying to solve the previous problem, the challenge number 3 I think, and using recursion. And as you might already know, when it comes to coding, recursion is one of the monsters that we have in our area, recursion and memory management and giving names to variables. I just want to make sure that we are on the same page when it comes to this video because I don't want to explain recursion itself, so I'm kind of assuming that you already know something about that, but I might be wrong, and because of that I'm going to record a specific video going through all of the crazy, amazing and ugly things related to recursion. So this will be this kind of, yes, you already know recursion, but maybe you completely forgot. So I just want to solve the previous problem with recursion, and maybe you will remember, or you have this kind of quick overview about about the way that you can solve this type of problems. Without further ado, let's get into it. Going straight to our online IDE, so I'm using, again, I always say in all of the videos because I don't know if you have watched the previous one, but I'm using this Ruby online compiler, which means that you don't need to have Ruby installed on your machine, which is great. And again, just a reminder, it doesn't matter if you're solving that with Ruby, Python, JavaScript, Erlang, Scheme, whatever. So this is all about concepts and logic, problem solving skills, and having fun. That's it. So I'm here with this. This was actually the previous one, the latest one probably. And as you can see, I have two methods. The first one, count prime number, which receives an array as a parameter. And then I have this is prime number, which is called when you have this block. So in the previous video, we have learned that we have this array dot count, which receives a block that can be an expression, that you will evaluate and that you will execute, and then Ruby will automatically count based on this evaluation, which is great. So you have, for example, count, let's say that you have 5 numbers, but only 2 of them are prime. Then this array count will say, hey, don't worry about that. I will count these 2 numbers based on this evaluation. So if I receive a really prime number, then I will automatically store that in my count variable that I have internally. So again, you can just watch the previous video, actually the challenge number 1 probably, and you can learn a little bit more about Ruby blocks. And then you have the most important, of course, method here, which calculates and actually validates if a given number is prime or not. So what I want to do is I want to create another method. Let's just create this is and the prime number, and then I'm going to use recursion. So let's indicate that. Perfect. Now, when it comes to recursion, we know a few things. Again, I'm not gonna go into so much detail here because I'm kind of assuming that you already know that, but just a terrible reminder. And long story short, recursion is when you have a problem and then you break that down into smaller problems that you can solve a little bit easier, or that you can just break that down and then come back to the bigger problem. And then this is one part of the problem, a big problem, and I have smaller problems, the same problem but a smaller one that you can solve. And then you have another important point, which is a method or a function that calls itself. That's it. So with these 2 definitions, I just want to make sure that you have all that we need to solve this problem. The first step that I want to take is, first of all, I know that I have this return false if item is 1. And that happens because we already know that 1 by definition is not a prime number, which means that I can just use this condition. This is a criteria that I have to use inside of this function. That's the first step. The second step is that we already know that a recursive function calls itself, which means that I can just say return, and this will be really weird, but return is prime number recursion. Okay, so we have the second step. The third step is that we already know that in order to call this function, this method, we have to pass something as an argument, which in this case I can still use item. So let's pass item as an argument. And here we go. That's it. Of course, this is not working, but I already know that these are the boundaries when it comes to recursion. That's it. So the third step is we already know that this is a for loop expression, which means that this for loop expression should stop when something happens. And we already know that item being dividable by number, terrible words to say. And again, if an item is dividable by number, which means that the remainder result is 0, then this is not a prime number. That's it. And when that happens, we know that we can just return false, which means that we'll break this for loop expression and then we go out, which means that I'm going to return true. Perfect. So we already know that if you have to return true here, in some way you have to return true here, right? If something happens. And the amazing thing is that do you remember the algorithm that you have used to solve the problem with prime numbers? So let's say, just a reminder, let's say that we are validating 6. So the problem, the logic that you break that down is trying to divide 6 by 5, by 4, by 3, by 2. And when you reach 1, you already know that that number is prime, because again, if the number that you are trying to validate is not evenly divisible by all of these numbers, that means that this is a prime number. So the logic is really simple. You can go back to the challenge number 1 or 2, probably 2, and you can see the complete logic. And now let's remove this. Actually, I'm gonna put this here. I'm going to keep this here because if you want to return true, you can actually you can guess what I'm going to do, because if you already know that I'm going to validate the number, I don't know what's happening here. Let me see, it's saving. Probably I'm gonna lose everything or not. Let me see. Okay, so it's here. What happens is that you already know that if you have 6, you will validate 5, 4, 3, 2 until 1. If you have, for example, let's go to another number. If you have, for example, 8, you will validate 7, 6, and 5, and 4, and 3, and 2, and 1, you stop that. Again, if you go to 3, I'm going to validate just 2, and 1 stops all of the flow. Which means that you can just say, hey, if you are calling the function itself, I have to pass the item, the 6, for example. Let's go back to the 6. 5, 4, 3, 2, 1 is the special. And I'm going to pass 6 minus 1. If I'm passing 8, 8 minus 1. 9, 9 minus 1. 10, 10 minus 1. So I'm going to pass this item and item minus 1, which is great because now I know that this item minus 1 is the number that will try to divide the item, which is great. So please, this recursive function, brilliant. Now we already know that if you reach, again, just to stress it enough, if you reach 1, that means that game over. You don't need to worry about this is prime function or method calling itself. So please, function returns true if the number reaches 1. because now you don't care. You already know. You already know if you reach number 1, then the number is prime. Now it's time to execute this code. So let me check if everything is okay. Count prime number, calling this, and we have this is prime, which means that I don't need this anymore. Let's remove, and then I'm gonna call this method. Perfect. If I execute this, oh, that's terrible. It's wrong. And of course, this is the developer's life. You know, I don't want to edit this video part because this is real life. You know, you always execute your code, and yeah, that's the problem. So what happens is that I will just pass item -1 as an argument. So that's the same thing that I'm doing here. Okay, and executing this, let me see the results. Whoa, that's terrible. It's not working. It's not working. And I promise that was on purpose. So what is happening here? The first thing that you can just guess, I'm not using number to be honest. So I'm using item. I should be using number. That's the first problem that I can see here. However, if I execute this code again, you'll see that the result is 9. And what happens is that, let me get the 6 again. You will try to validate 5. If 6 is not divided by 5, then you have to test 4 and test 3 and test 2 until 1. Perfect. So you go to the next one unless that number is dividable, which means that you go to the next one, you call the function itself again. If the item being divided by number is different from 0, right? So 6 being divided by 5 is different from 0. Then by 4 is different from 0. By 3 is different from 0. By 2. So you have to go, actually 6 is divided by 3. So in this case, 6 is not a prime number. But I'm pretty sure that you got it. So let's remove this again and let's execute this code. And let's see, whoa, it's working. So finally, this is working. And again, that was a terrible explanation of what is recursion, because that's not my goal here. My goal is to just give you this piece of code and just make sure that you will be aware of a way that you can solve the same problem using recursion. So again, if you have never worked with recursion, or if you have never studied recursion, then this will be a little bit hard to understand, and that's totally okay. In the upcoming video, probably, I don't know if this is the next one, but I just want to make sure that we will be on the same page when it comes to recursion. So I'm going to record a specific video going through all of these steps to solve a specific problem. And actually, probably I'm gonna solve 3, 4, or 5 problems, just to make sure that you guys understand recursion, which is great. You know, you have a lot of amazing things that you can do with recursion. So that's it for today, and I hope that you liked one thing or two, and see you in the next video.